Good evening, everyone. Can anyone? Yeah, am I audible, right?
Yes,
Yes,
you
ma'am.
are audible. Yeah.
Yeah, okay, thank you.
Good evening, ma'am.
Yeah, good evening, all. Yeah, this is like solve with instructor session. No, the thing is like the each question in the week eight practice assignment questions are very long. So if I make slides, no, so one part is coming in one slide, another part is coming in other slides. So I haven't made any slides. Just I will display the question, each question, so that you can specify, like if you have doubt you can ask. Okay, the thing is like I was unable to make presentation because the questions are very long. Okay.
Okay.
Yeah, yeah, I will share my screen now. Yeah, should I wait for some more time to let others to join, or should I start? Okay, we'll wait for 2 or 3 more minutes and we'll wait others to join. Yeah, you can go through the first question. Yeah, if you have any doubt you can ask in the first question. So meanwhile please go. Yeah, for others, those who have joined lately, please go through the practice assignment first question and try to solve it by yourself. If you have any doubt, you can ask. Yeah, later I will explain also. Yeah, you can
Hello,
ask.
ma'am.
Yeah.
I am not getting question point three and which my question.
You are not at all audible. Is it only for me or for everyone?
He is not audible now.
Okay,
Yes, ma'am.
yeah. Yeah, the thing is like now I am going to the practice assignment question. Please everyone have a look at that first question of the practice assignment. I will give to uh, 3 more minutes. Yeah, you can go through that question, try to solve by yourself. If you have doubt, you can ask. Yeah.
Ma'am, a general question.
Yes, yeah.
Ma'am, how many graded assignment we have to submit for the end term exam? Like at least how many?
Actually, I don't have that idea. Like, how many should you submit? Yeah, you can write something
I
in
think it is
Discord.
6. I think it's best of 6.
Okay, sir. Thank you.
Yeah, like you write in the discourse or forum. Yeah, we will answer you like correctly, like how many you wanted to write
So,
there.
sir, is there any average marks that out of graded assignment we have to complete out of more than 50 or more than 70?
I think you will get mail regarding this, no? Everything about all these general
Yes, yes.
things.
There is a instruction.
There is a requirement and it's mentioned in the handbook. You can check the handbook.
Thank you. Thank you. Okay.
Sorry, Hari, you are not audible now. Also, like it's not clear. I think you are network issue.
And you took a look at the first and the second question, right? Like those two, the practice assignment.
Yeah, practice assignment. Go through the questions. Like first, like we'll solve first question first, and then yeah, we'll go question by question. No.
Yes.
Yeah. Okay, I think I have given enough time. Like, yeah, uh,
Yes, ma'am.
yeah. Is it okay? Like, what is your answer for this question? Everyone understood the question, or you have some doubts? You can say now.
Madam, just in the initial part when the question is described, could you below the table
Okay. Yeah.
uh, interpretation of these sentences is a little difficult. Like, for example, in the other words, the art throw. Can you what does this say?
Okay.
This,
Okay. I will read each and every sentence for you. Okay. Consider the following condensed version of the train's dataset. There are total of n stations, with stations being indexed from 0 to n minus 1. Okay, there are total n stations in our train's dataset. I will use something to write this. Yeah. So so there are total n stations in our, is it visible, right?
Yes.
N stations, and with each stations being indexed from 0 to n minus 1. So we are indexing from 0 to n minus 1. Stations are indexed from 0 to n minus 1. There are m rows in the table. So in our this table has only m rows, no, 0 to m minus 1. Total there are m rows indexed from 0 to m minus 1. Each row contains information about the train that connects each row contains information about the train that connect two stations without any stops in between. So each row, this let us consider this 0th row, that is sequence number with 0. You are considering it as 0th row. Each row contains information about the train that connects two stations. So this is the train like 12259. It is connecting the two stations without any stops in between. Yeah, if you consider our trains data set also, like we also will have, no, like for each train number, let's take 12259, we will have list of stations through which that train passes by, right? In the train card, in that card we will have the list of stations through which this train passes by. So like if you consider, let's take one example as 12259 as our train card, and it will have list, sorry, wait. So it will have list of stations through which it passes by, no? So let's take this Chennai as one station, and next station, let's take Madurai. These are the stations through which the train passes by. Okay. And also other station, let's take Bangalore. See, now this 12259 is one train, and here this train will pass, is passing through all these stations, Chennai, Madurai and Bangalore. And so sorry, what happened here? Yeah, there, like if you consider that Chennai and Madurai, which I have told, which I have shown earlier, they're the train. So if you have considered that same thing, 12259 with Chennai and Madurai here, and also it has Bangalore station also. So here this train 12259 is passing through all the stations, Chennai, Madurai and Bangalore. And it has, see, if you consider these two stations, there is no intermediate stop in between, no? From Chennai we are directly, the train is passing, the next station is Madurai only, so you are not going to any through any intermediate station in between. So Chennai and Madurai are directly connected by 12259. All this information we are noting it in the table. So in this case our table will be, okay, if you are considering only the first this table, only this card, then our table will be 0 1 2 2 5 9 and So these stations are indexed with some unique number. So departure and arrival it's given, no? So here if you read this statement, for example, r throw, this r throw is here, this one r throw tells us that train t, this is the train t, departs from station I and arrives station J. So this is departuring. This author tells us this train T is departuring from station I and is arriving at station J. So each station is given an unique index numbered from 0 to n minus 1. So here the 0 and 1 I j, this 4 and 11, all these numbers in your box in this table represents the station numbers, like unique numbers given to each and every station. So I and j here is referring to the station. We are representing here as departs from station I and arrives to station J after covering d distance. After covering d distance. So if the distance is okay, here the distance will be to reach Chennai. Let's take if it is 256, and here if it is, let's take that will be like 356. Then here something like 700 or something. Then okay, yeah. Now this Chennai is given, this station Chennai is given index 0, and if Madurai is given index 1, and if Bangalore is given in this station number as 0 2, now our table will be 1 22299, and the train is departing from Chennai and is arriving at Madurai. So it is given 1, and distance is like 356 minus 256, 100, no? Yeah, and next in the other sequence number 1, the same train 12259, because we have this Madurai and Bangalore also. So it is departing from Madurai 1 and arriving the Bangalore station. This is Bangalore station is 2, and the distance covered between those station is 700 minus 356, something around 259 or something. 350 349 something. Yeah.
344.
Okay, 344. Yeah, 344. That's how our that box will look like. Yeah, is it clear, right?
Clear.
Yeah. So for example, Arthro tells us that train T departs from station I and arrives station J after covering a distance of d kilometers without stopping at any intermediate station. In other words, R throw in the table corresponds to two consecutive rows in the card. So this row R throw is corresponding to two consecutive rows in the card for train T in the train status set. So this is corresponding to your two rows, no, here Chennai
Yeah.
and Madurai. So that's we are telling. Therefore, each train T will occupy multiple rows in this table. So you have seen, no, here 12259, it is occupying two rows because it has three stations. So it is occupying two rows only. If it has many stations, it will occupy like n minus 1 rows, no? So that's like, yeah, here the thing is like each station will occupy each train. Therefore, each train will occupy multiple rows in this table. This scenario is modeled as graph and is represented by matrix A. Each node in the graph corresponds to a station. Assume that the value of n is already given to you. Consider the following pseudocode. So you are here it's given like each node in the graph corresponds to a station. So there is some graph like this, something like this, and this is 1 2 4. These represent station numbers. This node is representing one station, this 2 is representing other station, this 3. So each node in your graph is a station. That, and there are how many nodes there will be there? Assume that the value of n is already given to you, so there will be n nodes, no, in your graph. So consider this following pseudocode. S is an empty dictionary while table 1 has more rows. yeah, you are reading through this table only. You are filling your dictionary S. So S is an empty dictionary, and while table 1 has more rows, read the first row X in the table 1. So you are reading the first row, like you are iterating over this table. S of X dot sequence number equal to empty dictionary. So your S is, okay, your S is an empty dictionary, and you are iterating over the rows of your table, and you are telling S of X dot sequence number. Anyhow, our first sequence number will be like 0 only, no? And for that you are assigning empty dictionary. This is what the statement S of X dot sequence number equal to this empty dictionary, and you are telling S of X dot sequence number of train equal to X dot train. So in this dictionary, you are filling this dictionary now. 0 of, you are telling train here, and you are assigning X dot train. That is whatever train number, like 12259 in your train status set. So here train is this, yeah, 12259, and you are telling departure also here. So you are telling here, so here departure, and you are writing some number Z. Departure will be here number 0, comma, and also you are writing some, this everything will be in dictionary only, this whatever dictionary assigned to this, and also some arrival, arrive, and you are writing 1, and also there is other key distance with distance. I have written 100 no previously from Chennai to Madurai. So this is how you are filling your dictionary. And so you are iterating through each and every row of your table, and you are filling the dictionary S in such manner. Now A equal to create matrix of n by n. N is number of stations. So you are creating a matrix of n by n. So yeah. You are creating the matrix of n by n. So you are iterating for each row, for each row, for each R in rows of A, for each C in columns of A. That is, your A is something like this, A is something like this, n by n. This has n rows and also n columns here. For each R in rows of A, that is, this is, you are iterating over these rows like this here, and for each row, like this is inside this row, for each C in columns of A. So for each row you are iterating through each and
your worksheet is not completely visible, I think.
Yes, ma'am. It's not visible.
You're explaining somewhere and we are not able to see that portion.
Okay, yeah, sorry for that. Yeah, so for each R in rows of A, is it visible now?
Yeah, it's visible. Thank you.
Yeah, so for each R in rows of A, that is like you are iterating through each and every row. For each row, you are iterating through each and every column. So for each column in columns of A, so for this row, you are iterating through each and every other columns. Similarly, for next row, you will iterate each and every column. So that's how you are doing. So you are telling A of R of C equal to empty dictionary. So for this row, you will iterate through this column first, and you will assign it empty dictionary. Similarly, for the next column, you will assign empty dictionary. This will happen for each and every element in your matrix. So every element in your matrix will be an empty dictionary solely. Okay.
Okay.
Yeah. For each X in keys of S. So now you are iterating through your keys of your dictionary S. Yeah. S is, you all remember, right? S is some sequence number 0, and for each sequence number you have train number. 12259 something like that. And also, yeah, for no, for train, in the train you have train number and 12259, and also for arrive, departures or other keys it has, no. Yeah, so for each x in keys of s are equal to s of x of departure. So depart is some number. Depart is a number of a station from which it is departing, no. So r will be some, r will be like departure is 0 and c is like I told Chennai Madurai example, no, there r is 0. It is departing from Chennai station, which is given 0, and it is c is arriving at Madurai station, which I have given as 1. Yeah, so you are telling t equal to some that s of x of train, it will give you this train number. So t will be this 12259, and d is distance, d is 100. So what our dictionary, a of r of c, that is of t you are telling as d. So a of r of c, that is like here 0 and 1. 0 at row first column, so it will be here this row, 0 at row and first column. Here you are telling there is dictionary here, and you are telling t equal to d, that is like here the train number key will be 12259 and distance will be 100. So you will do this for each and every key of s, no. So for every 0 first sequence number, for every sequence number you will do, and you will fill this matrix A. Is it clear to everyone, or yeah, you
Yes.
can, yeah.
Yeah, it's clear so far.
Matrix A is the distance, is it?
Matrix is train number and distance.
Yeah, matrix A, you have assigned A as an empty dictionary, right? Matrix A, for every element of matrix A, you have made it an empty dictionary. You are filling it by checking that train numbers, each and every that from where what train is departing, and like from which station, this is station and this is also other station, no, departure and arrival. You are pointing out, you are going through that departure and arrival number, and you are filling that with that dictionary with train as key, train number as key, and distance as d. That is like, so you have this, no.
How does that n by n matrix look like?
That is how, yeah, I'm showing it here. So this is empty dictionary, and this is also empty dictionary. Now, okay, let's take this is our element. Now here this is first row and 0 at the column. That is, there is one train number with there is one station. You have given unique index to each and every station, no. One is, in our case, one is Chennai, and yeah, one is Madurai. Let's take, yeah, one is Chennai and 0 is Madurai, for example. Yeah,
I think
so
here Chennai has 0 and Madurai has 1.
yeah, it's okay, it's okay. Now, yeah, so now you are telling the train is departing from Chennai and reaching Madurai by which train, 12259, by covering which distance, like 100 meters. So this is how you are filling each and every this element. So this here also 0th row and first here, this is also 0th column, no. This is 1, this is 2. So from this, from 0th this station you are departing, and by which you are arriving through which station, by using which train. This all information is encoded in this matrix A. That is, you are departing from which station and you are arriving in which station, by using what train, by using which train, and by covering what distance. So all this information is encoded in this graph.
Okay.
Yeah, in this matrix. So if I comma j is a pair of stations, yeah, coming to the question, if I comma j are pair of stations, let's take this 0 and 1 are pair of stations, which of the following statements about the dictionary A of ij are true? So you are asking what all statements about A of j are true. Yeah, you can go through these options and you can tell.
We are unable to see your screen. It's only the worksheet.
Okay, yeah. Yeah, I'm solving this practice assignment first question only.
Okay. So we'll refer to us.
Yeah, you can now tell like for I comma j, like if I and j are pair of stations, which of the following statements about the dictionary of ij are true? The dictionary is like this dictionary are true. It is a multiple choice. So I think, yeah, if
Yes,
yeah, is
clear.
it clear for everyone? I hope it is clear.
It's
But
clear.
yeah, it's clear, right? If yeah, if you have doubt in the options, why other options are incorrect, you can ask. But I think it's very clear, no?
Yeah. This
Yes,
is very
ma'am.
clear.
Yeah, for everyone.
Yes, ma'am.
Hello, ma'am.
Yeah.
Ma'am, I think there is some problem with the graded assignment option for question 6. Can you please check it out, like option 3 and 4?
Yeah, we'll finish first this practice assignment questions and then we'll go to the questions later. Yeah, if
I think there is a problem with the writing the option, I think with the grammar of the option, like the statement.
Ma'am, for this question, actually, before going to the other one, so here each of these is a dictionary, row-wise. So the option 4, I can understand why it is not like correct. The value corresponding to key T of the dictionary is the minimum distance between stations I and J on T's route. What is that like?
yeah, minimum distance, the value corresponding to the key T of the dictionary is the minimum distance between the stations I and J on T's route. So you are telling, so this 100, whatever this whatever value we are capturing in your dictionary, you are telling this is the minimum distance between this station 0 first and whatever station I and J station. By using this train, you are telling this is the minimum distance. No,
It is
that
minimum distance between on T's route, right?
on
So
T's road.
so it will be always minimum, correct? It will be only one distance, one route only is there.
Because they are talking about only the
The
train
value
will not
correspond to-
stop any. The train will not stop any. Basically, this whole matrix is for trains. Only the starting station and ending station is there. That's all, right? Starting station, ending station. The dictionary structure is starting station, ending station, distance. That's all.
No, it has each and every intermediate station also, right? Start all intermediate stations also will be there. Like I have shown earlier also, right? Chennai, Madurai, and
Correct.
Bangalore example.
Yes, yes.
Yeah.
But in this value, the fourth option says it is the minimum distance between two stations on T's route. So T's route is always only one route. So it will be only one distance.
See, okay, you are considering only that thing, no? Yeah, there can be train also, like there will be also like opposite train also, right? Yeah, but train number will be different, no, in that case.
Yeah, train number is different.
Yeah,
And
the value
Train number is the key, is it?
Yeah, train number is a key. The value corresponding to the key
So basically, I'm trying to match between the dictionary and the matrix. So that I just like because we can have the matrix.
It can have two trains, right? The dictionary can have two trains and two distance. Are you mentioning that one, or it is not?
on T's route? Yeah, we'll go through this solution once what they have mentioned actually. Yeah, on T's route will be like we are talking about that only one specific train, no? T's route will be one.
Yeah. Yes. Only one train.
Yeah.
Can just pull up.
The solution in the pseudocode, we are initializing a dictionary s, and while loop we are storing the, in the while loop you are storing, you are still storing the details of train data set in the next dictionary, with the outer keys are sequence number and the inner keys are the names of the columns in the table and the values are the entries in the table. Yeah, and then we are creating a square matrix with number of rows as the number of stations, and we initialize each entry in the matrix as empty dictionary. Using for each loop in the last part of the pseudocode, we are adding key value pair to the empty dictionary in the matrix A. So using the for loop in the last part, yeah, you are adding key value pairs to the empty dictionary in the matrix A. For the rows and columns, the for row, the keys of dictionary for the row R and column C, the keys of the dictionary are trains departing from station R and arriving at the station C, and the value is corresponding to the distance traveled by the train T. Okay. Yeah.
You can just scroll up and just one last line, last paragraph, last sentence. For the rules, from the dictionary are the trains departing from station.
Where is a nested dictionary? It is only one train number and the distance value pair, no?
Yes.
Where is a nested dictionary he is telling?
Where is nested dictionary here?
Just can you scroll it up, please? Yeah, hold on there. This we're using while loop here. What are the details in the outer keys? In the second line at the end, where the outer keys are the sequence numbers and the inner keys are names of columns. Where do we get the nested?
This nested, this S, they are talking about S. In S, you have this next dictionary, you know, each sequence number you have initialized that as 0, and you have other this dictionary in the dictionary.
Yes.
Yeah, that dictionary they are talking about. So this here our question is this, no, A of ij is a matrix whose entries are dictionary with keys of the dictionary. With the keys of the dictionary, T are trains which are departing from station I and arriving at station J without without intermediate stops. Okay, and the values are distance D between stations and is not the minimum distance. Yeah, they're telling and is not the minimum distance, it's okay, but on T's route, yeah, this is somewhat confusing, no?
Yes, yes, it is confusing. On T's route, it is the minimum distance.
Yeah, on T, if you are telling only on T's route, yeah, I should talk with them. Yeah, actually, on T's route should not be there. The value of key and the value corresponding to the key T. So here, that is, you are talking about some particular train like 12259 of the dictionary is the minimum distance between I and J. You can't tell this, right? Like Chennai to Madurai, you are telling whatever. Now 12256 is taking like 100 meter, covering 100 meters distance and reaching from Chennai to Madurai. Now there can be other train like 122 some 60, it can take only 80 kilometers distance, no, and it can reach from
Correct.
Chennai to Madurai. Yeah, that is fine, but on T's route is
Actually, from
somewhat
the question, the first and third will automatically follow. I think from the structure. So it's very clear that first and third are following from the definition itself. Okay.
From the question description itself, the answers are available for first and third.
Yes. The others cannot be. You can ignore the second and fourth. Okay, we can go to the next one.
Yeah, we'll go to the next question.
What is the meaning?
Sorry, is anyone speaking? Yeah, we'll go to this next question. What is the length of keys of A of ij represent? So yeah, keys of A of j are train numbers which are departing from station I and reaching station J. So length of keys of those A of ij will what it will represent.
Number of trains
Yeah, number
connecting
of,
two stations.
yeah, without any stopping. So yeah, if it is clear, we'll move to the other question.
This is clear.
Yeah, for everyone.
Yeah. Right.
Yes, ma'am.
Yeah, okay. Then we can move. This is third question is like it's very simple question actually. Yeah, yeah. Okay, you can. Yeah, I think I will give some time for everyone. I can like this is like I need to scroll up and down. No, you can open in your own what on your portal and you can answer this. Yeah, I will give some time to solve.
Ma'am, in the meantime, can you ask a question from the previous question?
Yeah, but
The same,
yeah,
just
no,
you can
no,
scroll
no.
up
Sorry, it's this same. This here.
here. Yeah, yes, ma'am. Ma'am, here IJ, there will be many pair with length that would give the length and that length would give the number of train from station I to J. Many pair IJ.
Ma'am, if you are giving us 2 to 3 minutes to read and really make
Can
some
you get me?
understanding, please allow us to go through it and next discussion you can take it.
Yeah, the thing is, you can write in the chat. I will try to
Get
answer
me?
in the
I
chat.
mean to say. Oh.
Yeah, if you have finished solving, you can tell me, like, yeah.
Yes, ma'am. Okay. If others,
Yeah,
okay.
Yes, ma'am.
everyone.
Yes, ma'am.
Yeah, okay. Yeah, the thing here is like, yeah, for everyone, is it clear why there is error in those lines, or you have some doubt why it's error in line 3? It is an error.
Yeah.
And yeah, is it
Thus, the
Line
clear?
3
return
is
value is false. The return value should be minus.
-1.
Yeah, so here I of ij min is a procedure that accepts the pair of stations I and j and the matrix A as input. So this procedure should accept I comma j and a as input. It returns a train which goes from this I to j by covering the least distance without stopping at any intermediate station. So this procedure should return a train which goes from I to J. So it should return the train number. If there are no train connecting between these two stations, then the procedure should return -1. So if length of keys of I of this A of ij equal to 0, that is like there is no train which is connecting these two stations I and J, then our procedure should return -1. But here it is given false. So that's why there is error in this line, third line. And the pseudocode, yeah. So and there is error in line 7
Lines.
also,
And it should be keys.
because yeah,
It
here
should
it should be keys,
keys.
because you are iterating over this keys of, see, A of ij is a dictionary. A of ij is some dictionary, so each element in your matrix is a dictionary, so you should iterate over the keys. There is no rows, no, that's why there is error in this line. Yeah,
Yes.
and everything is okay in this pseudocode. That's why, yeah, error in line 6 and line 7, line 3rd and line 7. Yeah, everyone, have you understood this pseudocode? Like, yeah, if everything is correct, if this is -1 and if this is keys, yeah, is it clear to everyone? Like, here you are here this procedure will return the train number which is what?
Minimum distance.
Minimum
Minimum.
distance which is covering. Yeah, because it's same, it is same, like you are finding the minimum total marks or minimum marks in any subject. That is like
Yeah.
you are first assigning train equal to first of keys of A of ij, that is you are taking
The first train.
first train. Yeah, and minimum equal to A of ij of train, that is A of ij of train. This will give you the distance between this station I and j by using this train. So yeah, so you are iterating over the each and every key of your this A of ij dictionary, and you are checking whether this is minimum, if distance is less than minimum. Yeah, if it is less, then you are assigning minimum to distance, and you are telling this train, you are assigning this train equal to k, that is you are assigning that what distance,
Yeah. New train number.
new train number. K is this keys, no, for each k and keys of train. So k will be train number, so you are assigning the train and you are returning that number finally. Yeah, yeah, you can ask if you have doubt here in the pseudocode also. Yeah, we'll move to the next question if no one has doubt. Yeah, this is also easy question only.
Yeah. This is also okay.
Yes,
Yeah, is finished?
Yes.
yes, ma'am. Yes, ma'am.
Okay, is it clear to everyone?
Yes, ma'am.
Yeah, it's simple, no? This is like yeah, I and J are pair of stations. Which of the following statements are true? Yeah, executing after executing the pseudocode given below. So I to J you are setting false if length of keys of A of ij is not equal to 0. If there is one train, at least one train passing, that is passing from station I to station J, then you are telling I to J is true. Similarly, initially you have said J to I, you have initialized J to I to false. If length of keys of A of ij not equal to 0, that is if there is at least one train which is passing from this station J to I, station I, then you are telling J to I is true. And initially similarly I both J is false. So if I to J and J to I, if both are true, then I both J will be true. So by seeing the statements, you need to tell what are the following. If I to J is true and J to I is false, then I both J is true. So this just simply look at this condition. No, see if I to J is true and J to I is false. So true and false, it will give you false. No, I both J will be false in that. This condition won't be satisfied. So I both J will be false only. If I to J is, so that's why this option is incorrect, because here given I both J is true. If I to J is true and J to I is true, yeah, then I both J is true. So if both are true, then this condition will be satisfied and I both J will you will set I both J to true. Yeah, if I both J is true, then I to J is true and J to I is true. Yeah, it will be true only if both I to J is true and J to I is true. Yeah, if I both J is false, then I to J is false and J to I is false. You can't guarantee, right? Like if, yeah, you are using AND condition here, so this AND condition will become false even if I to J is false, or if J to I is false, or if both of them, this if I to J and if J to I both are false, then also. So here you are telling definitely, like if I both J is false, then I to J is false and J to I is false. It need not to be, right? Yeah, that's why this if this all the
But
three
this is
options,
partially correct.
this is this partially correct. The thing is you have this correct options, no, here exact correct options right here.
Okay, so we are wrong in that.
See, the thing is, right, the thing is this. So if I both J is false, then you are telling like I to J is false and J to I is false. It need not to be always, right? It is not necessary always, right?
Yes, ma'am. That's why
Yeah,
it's
that's
partially
why.
okay, ma'am.
Yeah, yeah, I understood why you are telling it's partially correct. But the thing is, there is exact option, no?
Yes, ma'am.
And the last option, ma'am, suppose if both if I both J is false and if I to J is false, if there is if, then we can say that I to J is uh, no, let me the before the last second, and then we can say it is false. If there would be if condition, suppose if I both J is false, then I to J is true, and then I J to I is false, then we can say like that, ma'am.
No,
See,
you can't say that. You
yeah,
cannot say that.
Suppose
yeah, Mohan Raj, you can tell.
if suppose if yeah,
Sure. If it says
and you can get me. Actually, I'm asking that suppose yeah. Oh, go on.
please finish the question. Please finish the question.
Hello. Yeah. See, my question is suppose if both ij is false, it is given. And then again, suppose if we add a condition, if I to j is true, okay, then we can say then j to I is false.
No, that's true.
Get me?
No, there is a or. Na? It is or.
Yeah.
Each one should be false. It can or means either one or both are false. That is or statement. The definition of or statement is either of them.
Actually, I'm just modifying.
You're asking about the last option, right?
Last second.
Last second, that is, it is definitely saying one is true and the other is false. We cannot say that, right? It need not be that case always.
Yeah, I'm just modifying the sentence like this. If I both j is false, and suppose if I to j is true, if we had if there, and then j to I is false. Can we say like that?
Yeah, yes. It's just like it's a maybe, right? Yeah, one of the options. If you use if, I think it is okay.
Okay. Is it okay, ma'am? Can you get me?
Yeah. Yeah, but he told whatever he told is correct. Yeah.
We'll do the next one, no?
Yeah, fifth question, no?
Yes.
Yeah, if is it finished?
2 minutes, ma'am.
Yeah, okay. Yeah, you can tell like whenever is it.
Yes, sir.
Yeah.
Yes, ma'am, you can start now.
Yeah. What do you think this answer is like? Yeah. Everyone got the answer, or you have some doubt in this question?
But
Please explain how to interpret using the code
Using the
from the
code.
code. Without seeing the option, it is difficult to
Yeah.
interpret.
Okay. Yeah. Okay. Wait.
Now we are able to choose the answer based on the details what we know of. Definitely not from the code.
Okay.
So how to read the code is a challenge, right?
Yeah. Some proc is a procedure that accepts three parameters: a train, a station, and matrix A that was computed in the previous question. Yeah, first question we have computed now that matrix. Which of the following statements are true regarding the return value are true? It is a multiple rate question. Okay. So this procedure somewhere here it is accepting train. The train is some train number. Station is also some station number. Like we have indexed it as 0, 1, so on. No, each station. So that number and our matrix A. So yeah, for each R in rows of A, that is you are iterating over each and every row. That is you are iterating over the station. So each row in your matrix A refers to some station only, right?
Yes.
Yeah.
Yeah.
So you are iterating over the stations only. If is key of A of this R of station comma train, that is you are checking whether this train is key of this A of R of station you are telling. So you are iterating over the stations. So for each R in rows of station, that will be like 0. Initially it will be 0, 1, so on to n minus 1. No, R will be 0 to so on n minus 1 because you are iterating over the rows. And station is some number which you have provided as input to the procedure. Let's take it as 3 or something. So and some train number. This train is also train number which you have inputted to the procedure. So let's take 12260. So you are checking is key. So you are checking whether this key 12260 is key of this dictionary. So each element in your dictionary in your matrix A is a dictionary, right? That is departing from this station 0 to station this 3 by using this train something. It's
Correct.
how, right, our matrix look this
Correct.
our yeah.
So
You are checking.
if this is false, what happens?
Yeah, let me explain. No, so you are checking whether this is a key, whether whether there is a train from this station to that station. That is this train should departure from 0th station and this third should arrive at the third station using this train. Yeah, if it
Correct.
is not a key, then you will come out of this if block. Yeah, you will come out of if block where this if block is ending here only, right? Yeah.
So it will return true, right?
Yeah, it will return.
True.
Yeah,
Correct.
let me see.
No.
Yeah, it will return true.
So what we interpret from this? If it returns true,
So
we say there is no train.
so it is returning true. When it is returning, is it let me check if is this inside. No, it is not returning true. See, this is not returning true, this is returning false. It
False.
will, yeah, it is, this true is inside the if block only, right? You check, please.
Oh,
It is for the for each block.
sorry.
Yeah.
Yes.
Yeah, so it is returning false. So if this condition is not satisfied, you are telling if the
then
condition is
then it will finish all the rows, and then if none is
yeah,
true, then it will be false.
yeah. So if this condition, if it is not a key, if the strain is not a key, like whatever condition we have checked is not happening, if it is not true, then you will go and check for this other row, that is like first row. So you won't return anything. You should complete this for loop, then only you will return something. Yeah,
So
let's
if
take
all
this
the rows are false, then it will return false.
false. Yeah, if all the rows are false, then it will return false. That means you can say that, so if all the rows are false, that is if there is no, like if these two, if there is no train.
Then we can conclude this is the starting station, is it? Because of this.
Yeah,
because it is not reaching from any station,
it is.
so it has
Yeah,
to be the starting station.
so you are checking whether you are reaching from 0 to 3 or 1 to 3, or yeah, you are checking for particular station, you are checking. So you are checking like from, for each and every station you are checking with that, like whether you are able to reach from this station to that station. So you can tell that the station is, so if this procedure is returning false, then you can tell that this station is not what.
It is the starting station.
Yeah, this station will be starting station if the procedure will.
All
Yeah,
the rows, for all the rows, if the first if is false for all the rows, then it means none of the station you can reach this station. So it means this station is the starting station.
Yeah.
Doesn't it means, ma'am, like there is no train between these stations?
No. You are no train. I mean, not between this station. This station cannot be reached from any other station.
Yes, this station cannot be reached from it. See, because you can't tell no train between for this station. You can't tell because you are iterating over this our trains data set only. There must be at least one train passing through your this station. So you cannot tell that there won't be any train passing through that station. So you are unable to reach that station from any station, from any other station. No, so you are unable to reach the station 3 from any other station. That means this station must be starting station for, yeah, the
For
station
this
must be
train number.
start. Yeah,
For this train number, this is the starting
station. Yeah.
Correct.
Yeah, for this train number, that must. Yeah, so for each c in columns of I, so if this condition is satisfied, yeah, if this is satisfied, if this is a key, something whatever we have checked, if it is satisfied, then you are iterating for each c in columns of A. So you are checking each and every other station also if is key of A of station of C. So that is you are checking each and every station
Station to
is
other
3,
station. This station to
station
other
to other station. So 0 so on to and all stations using
So
that train.
if this is false, the second if is false.
If the second if is false, yeah, you won't come here. So you will keep on checking every other.
You will return true, is it?
See, you will check. Yeah, you will check. So, but still this condition is satisfying. So the first if is satisfied and the inner if is not satisfied. So yeah, you will return true. The procedure will return true because
the procedure will return true. When it will return true, there is a
so this
completing the for each.
So this procedure is returning true. When this procedure is returning true, the second if condition must not be satisfied, and the first if condition should be satisfied. Only in that case the procedure is returning true. So when the first if procedure will be satisfied, if the station which you have inputted is the starting station for our train, then
No, but if it is first this is satisfied, if it is not the starting station, if there it can be reached from other station, any station, then it is true, right?
wait, if is key of A of R of train, so you are checking first row, like each and every station you are checking whether it is reachable, whether you are able to reach from any other station to that station using that train. You are checking, yeah, if it is reachable, and yeah, if it is reachable. Sorry.
And this 0 is a starting station and 3 is arrival.
Yeah,
Yes.
0 is departure and 3 is arrival. So you are, yeah, that is the thing, is like whether you are able to reach the station 3 from any one of those stations by using this train number from. So okay, let's take, we have inputted 12260. So let's take, like we have input our train number is 12260, and our station is 3 only, and you have given matrix A. So you are iterating through for each R in rows of A. So you are checking each and every row, that is you are iterating through each and every station, and if is key of A of R of station of train, so is key. So you are checking whether A of R of station, that is A of 0, this will change 0 to n minus 1 of station 3, and 12260 is key.
Yes,
So
ma'am.
you are checking whether uh, whether by using this train 12260, whether you can reach to the station 3 from any of the stations, like you are iterating through each and every station, right? So you are checking whether you are reachable to station 3, whether you are reachable to station 3 by using the stations, by using this. So
Train.
yeah, by using this train, so this train will pass only through the specific stations, right? It may pass, like, yeah, we'll take this situation also. 0 1 2 will take, if initially we won't take 3, and in the later case we will take 3, okay, for first initially. So yeah, if we follow this, if our train 12260 is passing through only 0 1 2 stations, so you are iterating all the stations, but no use, right? You need to reach from this stations to the 3 station using this train. This train is not passing through this third station, this station of 3. So yeah, you won't, this won't happen, this key will return false only by using those train. Yeah, this will return false. So what will happen in your procedure? Yeah, so it
So
will
it is
return false.
the 3 is maybe the starting station.
Wait, I think only one tab is visible, no, for you, or
Yes.
so yeah, this if is not satisfied, this is if is returning false, where this if is ending here, no.
Ah.
So this if is ending here, you have iterated through all the rows, like 0 1 2 3 so on, but you are not able to reach to station 3 by using this train.
Yes.
Yeah, so the thing is, like, what you can conclude, this procedure will return false for this.
Ma'am,
Yeah,
we are
this,
checking like station 3 lies in rows now.
yeah, but there is one condition also, right?
For a
Train,
particular train,
yeah,
a particular station lies in rows or not.
yes, you are
It will
checking, but you are iterating through each and every row of this matrix. That is, you are iterating 0 1 2 3 so on to n minus 1 rows. But the condition is here is like the train, but this train is passing through only 0 1 2. So yeah, if it is
I
a
thought
key,
it's the column, the station.
yeah, is it clear now?
Yes, ma'am.
Yeah, so this procedure will return false only, right? Because you have checked each and every row, but this condition is not satisfied. This procedure is returning false. When this procedure is returning false, here you are unable to reach to the station 3. Like this is by using this train 12260, you are unable to reach the station 3. That means 12260 is not passing through this station, passing to this station 3. You can tell now this.
Correct. Yes.
Yeah, so yeah, if this condition is satisfied, let's take if there is 3 also. If this our train 12260 is passing through this third station also, then you will iterate through each and every row, first 0th row, first second, first row, and this condition will be satisfied. A of 2 3, this will this using 12260, it will
Will be
give
true.
true. Yeah, this will be true. So you will iterate in this in inner statements, no? So for each c in columns of a, that is, you will iterate each and every column, that is each and every station 0 1 2 so on to n minus 1. You are checking if is key of a of station of c and train. That is like a of station is our 3 and c is like 0 so on. It keeps on changing. It will keep using the same.
Can you please write in subscript that what A, R, and station? It's a little confusing.
See, R is okay. I will use some table or something to understand this.
I'm like, we got the concept, but the notation are a little bit confusing.
Okay. So R is like station. R is rows of A. Rows of A is like train number, that station C. A is a graph in which each and every node represent a station. So rows of A will give you some numbers, that is stations only, no? It will give all. So A is a matrix n by n.
So indexes of the stations.
Yeah, A is indexes of station.
Departing stations, no?
Yeah, A is a matrix of n rows and n columns, right? So
Yes.
each row is a station. Each row is a station here, and each column is also a station. So you are iterating for each R in rows of A. That is, rows of A will give list of stations, and columns of A also will give list of stations like 0 to n minus 1 stations. So rows will give equal to 0 to n minus 1 so on to n minus 1 numbers. Each number will represent some station. Columns also, columns of A is also some number 0 to 1 2 so on n minus 1, that is each number is also a station. So for each R in rows of A means you are iterating over the rows of the A, that is you are iterating over each and every station. Is it clear now?
Yes, ma'am.
What is R? So you are checking if is key of A of R of station. Station is some station number which you have inputted, and train is also a number which you have given to the procedure. Some procedure you have inputted train number. Train is the train number and station is the station number. Let's take, okay, wait, yeah, let's take this some procedure. You are inputting train number as 12260 and station as 3 and enter matrix you are inputting. Now for each r in rows of A, that is you are iterating over rows of A means stations. Is it clear? Right? Yeah.
Yes.
If is key of A of R of this, you just fill the values here. So if is key of A of R, R is like each and this will change, no, R will change in each and every iteration. So in the first iteration it will be 0 and station will remain same, STN. This will remain same in each in every iteration, and train also, it also will remain same, the things which you have inputted here. Yeah, only this will change. So you are checking whether this train is key of this. Previously, have you remembered however this matrix A will look like? It is a dictionary, each it will have some train number and also distance. So this will indicate like, this is indicating like you are passing through from 0th station and reaching to first station by using this train number by covering this distance D.
But ma'am, without like looking into metrics, how can we know like this train is going from this to this? Like we are, searching from rows, na?
Yeah, you should look at this matrix, no, that's why you have inputted this
We have to
matrix,
go through
that's why
columns.
this matrix is given.
The column will be fixed in this case, the third column, or third or fourth, and then.
But the next, but if this 3 is the column, then in the next if station we are iterating from AJI.
See, the thing is, when you are iterating through this, only if this first if condition is satisfied, no?
Ma'am, but in first if condition that R is for rows and S station is for column, third column.
Yes, yeah.
Okay, and in the next if state, okay, let's continue then.
Yeah, so I have explained this also, no? If this condition is not satisfied, you will check each and every row. Previously I have taken 12260 example, and I have given some values like 0 1 2. If our train is passing through only 0 1 2 stations, then this procedure will return false only, because this condition, first if condition, won't be satisfied at all even after iterating through this for loop. So this procedure will return false. And yeah,
Ma'am, we are checking 3-4 columns now.
Yeah, 3-4 columns also you will check, but this train, this train won't be there, no?
If rows do not have 3, then what is the problem? Like if we have
No,
columns,
this is not the rows.
It is for row now.
No, it is not the rows here. What is mentioned?
Doesn't it mean like we are checking every departing station that are represented by R in the rows to a particular station which is in column?
Yeah, you are checking, but this train also is there, no? You have inputted some train number. You should check whether you are able to reach from that station to the station, whatever you are iterating all through stations, no, whether you are reachable from R to station using this train, you have to check. So yeah, there can be some other, see, you might be able to reach from this like you can be able to reach this to the station 3 using other trains also, right? 12259 also. But the thing is like only 12260, this train should take you to this
Like you are saying, we are not having number 3 in rows. We are only having 0, 1, and 2. But like we have, then our if condition is like is key A 3 3, then why a train will go from a station number 3 to 3?
Yeah, you can go from station 2 3 2 to 3, no, in that case.
That condition, the condition will be true now. Like
Yes,
two
that
to
condition. Yeah, that condition will be true in that case. So yeah, now I am assuming like this train 12260 is only passing through 0, 1 and 2 stations, not the third, not the station 3.
Okay, ma'am.
So this procedure will return false at that time. So the thing is like you are unable to reach from, if this procedure is returning false, it means that you are unable to reach the what, you are unable to reach to this station using that particular train. Yes, no? Am I
Yes.
audible? Yeah. Okay.
Yeah.
So if there is some station 3 also in your this 12260, then this will return true. Is key. That statement will, that condition will return true. From 2 to 3 you can reach, no? So yeah, this will return true. You will check here. You will go inside this for loop. For each C in columns of A, if is key of A of station of C of train, that is like you are checking whether A of 3 to some number using that train 12260. The thing is like whether you are checking whether can you reach from 3 to any other station using this 12260, like whether, see, if you are at 3 here, can you reach to other station, like how you have filled your what your this matrix by keeping like you should depart from this station 3 and you should arrive to other station 0 by using this train number 12260. See, but this is not happening, right? Because this is your last station, so you are unable to reach from station 3, like you are unable to depart from station 3 and reach to station 0 using 12260 because this is your ending station, right? So if this condition is not satisfied, then this will return false. So it will return false for each and every, even if you have iterated through n stations, this will return false. So this condition won't be satisfied, so you will come out of this loop.
Yes, ma'am.
And yeah, and this procedure, but you are still inside this if loop only, so this procedure will return true in that case. So if this station is ending station for your train, then this procedure is returning true, and this is returning false if you are unable to reach to the station 3 using that train. So yeah, we'll take this some other example. If there is something like 4 also here, now here you are able to reach from 3 station 3 to 4 using this train number 12260, then this inner if condition is satisfied and this procedure will return false. In that case, our station 3 is not ending station, then our procedure is returning false. Yeah, it is returning true only if our station, our this station 3 is ending station of our train.
Yes, ma'am. Yes, ma'am.
Yeah, is it clear or?
Clear.
Yes, ma'am. Now it's clear, ma'am.
Okay. So yeah, so some procedure returns false if the station is starting station. Yeah, it will return false if our station is starting station of the train, because this condition will return.
This is the last. This is the last return, right? The last return is the last statement.
Last statement.
Statement. The last.
Your voice is not audible properly.
Sorry.
Yeah. Now you can speak.
In the pseudocode.
Yeah.
If the
I think there's some network issue from my side or for everyone.
You are audible, ma'am.
But he is not audible, right?
Ma'am.
Yeah. Yeah, I think Yeah, the some procedure returns true only if the station is sending station for the train. Yes, some procedure returns false if the station is an intermediate stations on the train's route. Yeah, it will return false, no, because if you are able to reach from station 3 to 4 using the train, then this procedure is returning false. That means the station should not be intermediate station. Some procedure returns false if the station is not on train's route. Yeah, in the initial case also, like I have taken only if the train is passing to 0, 1, 2, then the procedure will return false because you are unable to reach to the station 3 using that train. So this, yeah, some procedure returns false if the station is not on any train's route. Yeah, I hope now is it clear. Yeah, please, I will give 5 more minutes. Please go through all these practice assignment questions. You can ask like whatever doubt you have in these questions. Yeah, 5 more minutes I will give just to make, just to confirm from everyone.
Ma'am, this edges, no ma'am, nodes and edges.
Yeah.
Do we have a relationship in the sense if we have so many nodes, say we have 10 nodes, then the edges will be n into n minus 1 by 2, is it? Is it that way?
See, edges, it's not necessary, like
not necessary that way. Okay.
Yeah, so edges, like, yeah, like no edges can, only one edge can be connected in a graph, right? So the thing is like, okay, if some student is a topper, then yeah, then he won't get connection. See, if you're telling like,
or will it for direct proofs, because there is one activity question 8.3 where they have used the formula. Actually, I couldn't understand the problem also.
Okay, yeah, we'll go through that, but first take this 5 more minutes and see each and every this practice assignment question.
Okay.
Ma'am. Hello.
Yeah. Yes.
Yeah, ma'am. There some procedure return true if station is ending the station. That will be returned when if it's last and that station will be executed after the end of if the first if.
Yeah, this procedure.
Just or in the middle.
So if you are, if this, if this first if condition is true, then you will check all the statements. No, so yeah, if after checking all the statements, if the procedure is not returning, if the statement return false is not executed, then this procedure will return true. So yeah, when it is returning false, if it is an intermediate station, like if we can reach from station, this station, whatever station which you have inputted to other station, then this will return false. If not, if you are reachable from this if you are reachable to this station using this train, then, and if this station is the ending station of your train, then this procedure is returning true. Yeah, Ravi, you can tell your doubt specifically, like, yeah, you have.
Ma'am,
I don't know why everyone are not audible. Is it only for me or for everyone?
No, ma'am, for us as well.
Okay, yeah. Okay, should I? Okay, so I think I have given enough time. You can
ma'am,
ask you.
ma'am, can you please go to the code sheet?
Which thing?
Last problem.
Yeah.
The code. No, just little bit scroll down. No. Other way around. Just start of the code. Yeah, just hold on, please. Here. Now, in the first if condition, no?
Yes. Yeah.
When it becomes false, it could be starting station, is it?
It could be starting station, or if the station is not on the route at all.
But now, how to resolve these two issues now? Whether it is starting station or a station is not there. Between these two, which is the one we are going to select?
Both are true. Both
are
may be
true. Yeah, now the question is, which is the one which will be taking it? Both are true.
Yeah, but there are options. No, you can check in the options. Both are true. The question can be like that also. You can check options also in that case.
Two options will be right for that statement. When it becomes false, okay, that's the way. But how does the real code will work? If that, it should not be that way, no? Should be.
Yeah, then you can tell it will return true only in that case. No, if this is returning false for the see there can, so the thing is, like, you can't come to a final decision by just checking the one condition. You should go through the complete code, no,
There
to
should
get
be
some.
another if condition should be there, is it, to really resolve these two, whether it is a starting station or it is not a station?
Yeah, the question is yeah, but the question is regarding ending station, no? Yeah, if you have gone through this completely, then you won't. After looking the options, yeah, everything will be clear, right?
Even in the full code also, that issue is not getting resolved. That is still remain open only.
correct. Yeah, in this code, you are not differentiating whether it is a starting station or it is not a station at all. That you are not.
That is not being addressed in this code. Okay.
Yes,
Yeah,
that is.
both depends on the last false.
So that way there will be two options correct, is it?
Yeah, I think so.
Is it that way?
Yes.
So see, some procedure returns false if the station is intermediate station on the train's route, and is also returning false if the station is not on train's route. See.
So both these statements are.
It should be, when it is false, it should be either a starting station or the station is not.
This also some procedure returns false if the station is starting station for the train.
Okay.
The statement is also there, right?
Now there is a third one is also coming up now. So I was
if the first if is not executed at all, then the option 1 and option 4.
Yeah, option 1 and option 4.
Where is it? Option 3 is coming, and what condition option 3 is coming?
That is that inside, if the second if is executed, then again it is a false.
False, right?
It's a false condition. Is it a false condition? Is it? Inner loop and outer loop both are false.
First should be true and second should be first should be true and second condition also should be true. Then this procedure will return false. So first condition will be true when the first condition will be true, when there is the station in this
Station is there.
train's route. Yeah, when, yeah.
What is the option 3 then?
That is true. That is if the second if inside if is not executed. Then
No,
it
option 3 is option 3.
sorry, option 3 is intermediate.
In the
That
answer, in the accepted answer, option 3, what is that?
that is inside second if statement is executed. If the second if statement is executed, there is a return false inside the if. So if this return false happens, then it is an intermediate station.
If the return inner loop return false, then it is an intermediate station. No, I'm missing the point.
See, the thing is like you can reach from this whatever station you have inputted to any other station using this train. If you can reach from inputted station to any other station, then this procedure is returning false. That means this station, the inputted station, must not be intermediate station. If it is an intermediate station, you can reach the other station, right, using this train.
Oh,
in that case, the procedure is returning false. So this procedure returns false if the station is an intermediate station on train's route.
No. Can you go back to the code, ma'am? Yeah. The inner loop, if it is true, then it is not going inside. It comes straight out and it picks the value return true there. Is it?
If it is not going inside,
not going inside,
then
the return true value is coming after second flower bracket. Is it? That's the value what it is going to take. And it becomes an intermediate station. Okay.
No.
It is not becoming intermediate station.
It will become end station. Only if it goes inside the inside if statement, then it is an intermediate station.
So that time return value is false.
Yes, false.
Yeah, okay. I think enough. Yeah, we'll go to this activity. Yeah. Activity question, which, yes, other like someone is pointing out.
8.3. Yeah, this one. Yes, this is the one. Now, how do we read this code, ma'am? If n is the length key stations, then what will be the value of a after the execution of the following pseudocode? Here, station index is a dictionary which is described in the procedure directories. That is, the train goes directly. You don't have to, hop over. That's what they mean. No, when you meet, say, direct routes.
Yeah, direct routes is like, you can reach from station I to station J using only single train without no intermediate stations in between.
Yeah.
The station index is a dictionary which is described in, okay, for each y in keys of station index, okay, a equal to a plus station index of y. So a will be incrementing after seeing this. If there are n stations, then so station index will have keys from 0 to n minus 1. So our this for each y, it will become, in the first case it will be 0, in the second iteration it will be 1. So it will be like a equal to 0 plus 1 plus so on to n minus 1. So what will be the sum of n minus 1 natural numbers? No. So n into n plus 1 by 2. Instead of n, there is n minus 1. It will be n into n minus 1 by 2.
So this, for if you can give example for each y in keys, the station index will be the numbers, is it?
Yeah, station will be integers from 0 to n minus 1.
Okay.
Yeah.
So the keys, they say, the direct routes, how many keys for 12259 they've asked. So it is a starting and the ending station.
Ending station. Yeah,
yes.
Direct routes, no? 2.
Yes,
there will be 2 only, no?
Okay. No, I just wanted to know whether I've understood it correctly or it was just an assumption.
No, like, yeah, for every train, like if you take 12259 in our dictionary also, in direct routes also, whatever, like in the lecture also, it is mentioned, no? Only the station I and station J will be counted, which is the starting and which is the ending of that particular train in the direct route.
Ma'am, the same activity, the last question, ma'am. Last one. This one.
So yeah, if the consider the following pseudocode if condition is not satisfied for I equal to 2 and j equal to 4. So which condition? This if condition is not satisfied for I equal to 2 and j equal to 4. What will be the output of the statement? Is key of one more hop of 2 comma 4 if executed in the procedure. So you are executing is key of one more hop of 2 comma 4 executing after this if condition. So okay, let's go let's iterate this. For each k in columns of direct, so you are iterating over this train number solely, right? Not train number,
Yes.
station number solely, right? Yeah. If n hops
So
of
what does this columns direct mean? This direct, what is the value it will have?
columns is, see, direct is a matrix.
Okay.
Actually I'm also not clear, but I hope like direct is a matrix with see, you are
There is a direct string.
so direct must be a matrix because you are using it as a matrix.
Okay.
Yeah, wait. Only one screen is visible or both screens are visible?
Now only
Now
one.
only one is
Now,
visible, ma'am.
now no screen.
Okay.
What I understood is if there is one train from one I to K station, then from K to J. So this one more hop will be, you just make one hop and you reach your destination. But I couldn't understand this I equal to 2 and J equal to 4.
Okay. So you are here it's given that the if condition is not satisfied. This if condition which is mentioned in here will not be satisfied for I equal to 2 and j equal to 4. So if here, see, if I is 2 and j is 4 here, then this if condition won't be satisfied.
Right,
That is given in the question. So yeah, what is the output? You want to check the output for is key of one more hop of 2 comma 4. So yeah, one more hop must be a procedure. What it must be a dictionary because you are using is key, right? So is key of one more hop of 2 comma 4. So you are checking if here I is 2 and j is 4. So you are checking here. The thing is, right, you will iterate through each and every columns of direct. No, columns of direct will be 0 to n minus 1. That will be the train
Yes.
numbers.
Yes.
So if n hops of I to k, that is like if I is 2, then in our iteration k will be like 0. No, 0 in the first iteration, k will be 0. If n
Okay.
hops of 2 to 0 is 1, and yeah, this is 2 to 0 and 0 to 4. J is 4. You should assume like I as 2 and j as 4 because it is mentioned in the question. And k is like changing like 0 to n minus 1. Yeah. So in that case, you should keep those values in this and you should check. So if 2 n hops of 2 to 0 equal to 1, and if there is direct so n hops of 2 to 0, that is if you are able to reach from station 2 to station 0 using n hops, then this will be 1. And direct of 0 to 4.
4. Okay.
Yeah, then this will be if there is something, if there is a train from what 0 to 4th station, you can reach using only one train. If you can, then 1, it will be 1. So in that case, one more hop of 2 to 4 also will be 1. So yeah,
Madam, you are saying the if condition is not satisfied, right? For 2 and 4.
Yeah, if
means
condition won't be satisfied for I equal to 2 and j equal to 4, what
so
will
it
be
means
this?
there is no train. Then one more hop, 2, 4 must be 0, right?
So you can't reach from 2 to 4. Yeah, the thing is it's not mentioned, right? If you can, if this is like, you can't reach from station 2 to 4 directly, or by using intermediate station if you can reach, that is not
No,
mentioned in the question.
it says if statement I and j are 2 and 4. So it means through any of the k, it cannot reach, right? This if is not executed, it says.
It won't be like that. No, see, the thing is, if you can't reach directly from station 2 to station 4 by using
No,
single
no,
train, but if
no,
you
it
can
says
reach
if
using
condition.
intermediate trains, what?
So,
No,
for
it says if
example, ma'am, if we take now, let us iterate. If you take first I as 0 and k as 1, 0 and 1, and hops that is equal to 1. Say there is a train between I and k. Okay, station.
Okay. Yeah.
Okay, 0 and 1 station. So 0 and 1, they didn't say we can't take it. So that is equal to 1.
Yeah, the thing is like, yeah, this is clear right now. So the thing is like, you can't reach from station 2 to 4 directly, but you can reach, you can use intermediate station, like you can go
use
from
one
2
more
to,
hop.
yeah, you can use one more hop and you can reach, no, like you can go from 2 to 3, and from 3 to 4 you
Or
can
you can go.
go,
Okay.
yeah, in that case our one more hop will
Ij
return
will
true.
become 1, and that is
One true. Yeah, that is true.
that is how
But
we should understand. I was not sure, ma'am. That's why I wanted the clarity. Whether
yeah,
what I assumed is right.
actually the thing is like, yeah, I haven't gone through the lectures to understand this. Yeah, but the thing is, yeah, but this, yeah, but I remember this how the assumption should be, like, yeah.
Ma'am, going through lectures is different and seeing the problems is different, ma'am. To understand the logic, it takes a lot of time as we are going further.
Yeah, I can understand, like, yeah, lectures are
But when
completely
you
different.
explain it, it appears to be simple, but we are not going to get similar problems. Each problem is different.
Yeah, each problem is different, but in the exam, no, you will give only like for like 1 hour of time. If you have given like 2 to 3 days, then it will be easy for you, like, yeah, because you will be going through the questions, like you will sit yeah, that.
Ma'am, just a question here. This key is key one more hop 2 and 4, right?
Yes.
It is checking whether there is a matrix position of 2 and 4, correct? That's all. It is
So
not checking whether there is a train or not. Whether
there is mapping from, so one
whether
more
there
hop
is
of
a
2.
matrix element, whether there is an element between 2 and 4, whether there is an element, right?
No, is
It is
key, no,
it is
then
not
that is a dictionary, right? One more hop is a dictionary. In that,
correct.
yeah,
Whether
in
4
that,
is there or not, whether the
4
train
is a,
is not,
yeah,
whether
whether
the train
4
is there
is
or not
a,
is.
yes, yeah. The thing is whether this is key will return true or false. Our
So
condition
is
is.
key will be always true, right? Irrespective of any of the situation, because you're in, because it is a matrix, correct?
The thing is like, you may not reach from station 2 to
I
station
think
4.
this is not talking about whether it is reaching or not. It is telling whether the matrix is mapped, whether there is a column 4 and row 2. There will be row 2 and column 4. It could be 0 or
Yeah,
1.
yes,
In
yes,
either
yeah,
case, it is true.
yeah. So the thing is like, here you are checking whether
So the matrix,
one more hop is a matrix in which you are checking second row and fourth column, whether there is second, whether 4 is there or not, you are checking, right? In this yeah, the thing is like, I have not gone through this one more hop. What this one more hop
no,
is a mat.
one more hop is also a matrix which will return
Okay.
1 if there is a connecting train. But in this question, whether there is a connecting train or not, 4 will be a member of the dictionary.
Yeah, 4 will be the member of the dictionary because each and everything will be there in your in your
Yes.
matrix, no?
So it will be always true. That is why even if the if statement is false, not satisfied, it will be true. Always.
Yeah, but I can't, I can't tell this clearly. Yeah, but it seems what correct. Yeah, I will go through this and this one more
Where do we stand after such a long discussion? Is it true or false? I feel
It's
it's
true.
true. I feel
It's
it's
true.
true.
Yeah, it's true only.
Yeah, but why do we really have such a long discussion? I do not understand the scope
The
for
thing, the thing is like I haven't gone through this, and also
No, what are the alternative
y-
approaches? Because it's
uh,
the way
actually
only
it's not. No, actually it's not clear for me what is one more hop. Is it is it should be a, so one more hop of 2 must be a dictionary and one more hop must be also a dictionary, because you are telling, yeah, it is a next dictionary in which you are checking for both cases. I can make only that.
when I read these two lines of codes, no matter whatever be the intermediate station, we are definitely going to have the third line as one, is it?
No,
Is
no.
there any other way of really not making that as one?
Yes, yes, because
How?
I and K can be 0.
Okay, let that be 0.
So if
Assume that it is a circular train. It goes to
no,
2 to
if I
2 to
and
0
if
0
I
to 4.
so if from I to K you cannot go, it means that is 0.
Why?
And K to, if n hops returns ik is 0, means then you will not go inside this if loop.
Now, why don't we think this way? If it is a circular train, it is somewhere in some station, it goes to I to K, from K to J it can go.
See, in the question they say the if condition is not satisfied.
If condition is not satisfied.
Yeah.
Yeah, they consider the pseudocode if the condition is not satisfied for I equal to 2 and j equal to 4. Yeah, if this condition is not satisfied, then what will be the output of the statement is key of one more hop of 2 comma 4. This, yeah.
The point here is the is key does not depend on this code at all. The is key will always 4 will always be inside the dictionary because that is a matrix. Therefore, it is true.
Then
this code is only to distract.
Yeah, this code is only to distract from my previous knowledge. Like, yeah, I can tell this is code just to confuse you. There is nothing. Yeah, the thing is like, because it is a matrix, each and every like 0 1 2 so on to n minus 1 like will be there, no? So 4 will be there in this matrix. So this will return true without checking this.
Yeah, I
this
need to
pseudocode.
see if the condition is not satisfied. Reading this code is confusing. And taking the true value is difficult to take. All right. Thank you.
Yeah, okay. Yeah. If
Ma'am, I do have a question, but this is regarding week 7. Ma'am, a general question. Like there was a question from where we have to convert nodes into graphs and matrices. Ma'am, I face problem converting nodes, the graphical structure into adjoint matrices.
yeah, if you need to like adjacency matrix is nothing but you are see if there is connection from one node to other node, you are representing that in the matrix from. So if there is like so let's take like there are 5 nodes, 0 like 1 2 3 4 5, and
Yes,
if
ma'am.
1 and 2 are connected by 1 in your adjacency matrix, yeah, I will show you that. I can show you that.
Ma'am,
Okay.
so I just get confused that whether 1 is the row or 2 is the row or which is the column part. I have to enter.
So yeah, now you have this nodes like one. I will write here. Okay, 1, 2, 3, 4 and 5. Okay, if in your graph this 3 and 4 are connected
Yes,
by
ma'am.
1, and if 2 and 4 are connected by 1, and if 1 and 2 are connected by 2, then you should, in adjacency matrix, like there will be 1 2, like, but it will be indexed from 0 1 2 3 4 only. Okay, we'll take 1 2 3 4 5 better understanding, for better understanding. 2 3 4 5, 1 should also be there. Oh, have written is 1 2 3 4 5. Yeah, now from, so you will iterate from this, for this first row you will iterate through all these columns. So this, so you will check whether there is connection from 1 to 1. No, right? 1 to 1 you don't have something like 1 to 1 connection, so it will be represented as 0. From 1 to 2, yeah, there is 2. If it is a directed something like this, then 1 to 2 there is 2, and for 1 to 3 there is no connection, so it will be 0 in your graph. And from 1 to 4 there is also no connection, then it will be 0. From 1 to 5 also there is no connection, then it will be 0. For 2, for 2, like 2 to 1 there is no connection, you have from 1 to 2 only there is a edge, so 2 to 1 there is nothing, so it will be 0. From 2 to 2 also there is no edge, so it will be 0.
Okay, so
From
the
2 to 3,
arrowhead represent the column and the arrow tail represent the rows.
so you should iterate to, so you are picking first row first, and you are iterating through each and every column. So that means you are taking, you are fixing this row and you are iterating through each and every column, that is you are iterating through all this element. Similarly, you are keeping this first second row this fixed, and you are iterating through each and every column. By doing this, you are iterating through each and every row and each and every column, that is you are iterating through each and every position in your matrix. This is done by using nested loops. So you are fixing rows first. In each row, for each row there will be one nested this for loop. In that you will iterate through each and every column.
Okay, ma'am, so can there be a double headed arrow?
Yeah, if it is undirected, if there is no this something like this, some edge, then
Yes, ma'am.
this is this 1 and 2 are connected, and 2 and 1 are connected by 2. So from 2 and 1
Okay,
also there is 2.
like
That
a
is,
symmetric matrix.
yeah, that is, it is a see, if both are connected, then you can say it is a clique. No,
Ma'am, what does this mean?
so see, if both, if 1 and 2 are connected, then it is a clique. So if everything, if 1 2 3, if every, so if each and every node is connected, so that is like from 1 to 2, you, from 1 you can go to 2, and from 1 also you can go to 3, from 3 also you can, so that means from this fourth node, or for any, from any node, if you are able to reach any other node in your graph, that means it is a clique. So that means each and everything should be connected to each and every other thing, then it is a clique. So but if there, you told no, it is a symmetric matrix, that means if the, if it is undirected, if there is no connection, if there is no arrow something like that, then you can tell there is like 1 and 2 are connected by 2, and 2 and 1 also, like from 2 to 1 also there is 2. Okay,
This is adjacency matrix, ma'am. In this, whatever example you've given now, like this matrix. So, what is this adjacency matrix?
that adjacency matrix is just what, representation of the what graph. See,
Okay, in this graph, 1 and 2 is connected. 2 and 4 is connected.
Yeah.
So
2 and 4 are connected by 1.
Okay.
See, just you Google no, what is adjacency matrix. The thing is like, whatever it is there in the graph, if you are representing it as an matrix, then it is called as an adjacency matrix only.
Okay,
No,
okay.
yeah.
Hello, ma'am. Like I have asked before that about that graded assignment question. There's some problem with the options maybe. Can you please check question 6 of week 8 graded
Question
assignment?
6 of week 8.
Yes.
Yeah.
Option 3 and option 4.
The submission date is not finished, huh?
But there is some, I think, grammatical error with the options. Like it is given list of authors who quoted at least a book, like at least how much book. It's not given at least how much book, so it's not given there. And the fourth option, it is given either I and J. So either and like that's also a problem.
Yeah, we will look at that question and we'll tell you. Okay.
Okay, ma'am.
Yeah.
Ma'am, in 8.4 activity question, that is one question. The procedure one hop distance finds the minimum distance between two stations, which has only direct connect. That means A and B are two stations, which has a direct connect. And how this one hop distance comes, that is the direct connection itself is one hop distance, is it?
Which question you're talking? Sorry,
8.4.
like actually I have
8.4,
closed
ma'am.
that.
Oh, you closed it, ma'am.
Yeah,
It
I have
is
closed that.
8.4, third and fourth, ma'am. I wanted to know whether I've understood it correctly.
Uh, 8.4.
8.4 activity question 4, 3 and 4. She said.
Yeah, what you can tell your doubt here actually. Yeah, I can't share the screen because my network is like not good.
Okay. Actually, the question is the procedure one hop distance finds the minimum distance between two stations, which has only direct connect.
One hop distance finds the minimum distance
between two
stations, which has only direct connection.
So it is false. The answer is false, right?
Yeah, the answer is false.
So therefore, it does not store.
What is this minimum distance between two stations, which has only, see, how does the distance matter in this?
The procedure one hop distance finds the minimum distance between two stations, which has only direct connection.
See, A and B are directly connected, ma'am. Okay.
Okay.
Then there is no question of one hop distance. No, it is a direct thing.
Yes, one hop distance. The hint is also, feedback is also given. No, one hop distance always store the direct distance between two stations. Okay.
So it says only direct connection. Even if it doesn't have direct connection, it will store the minimum distance. If it has direct connection, one-hop distance matrix also will store the same distance.
Yeah, actually.
One-hop distance matrix will store direct matrix values plus additional values.
Yeah, it will store the direct connections distance value and also additional value. The procedure one hop distance finds the minimum distance between two stations which has only direct connection.
So the last words, only direct connection, is wrong. Therefore, the statement is false, as by the answer given also.
Yeah, the thing is like what?
But it is surprising why this question is asked.
Yeah.
And even the next question finds a path between two stations. One hop distance finds a path between two stations, which has at most one hop route.
It will find also all the distance, no?
All the distance. Okay, that's what it is. Okay.
It is false.
Okay.
But the thing is like one hop distance is calculating only the distances, right? It's
Yes.
calculating the distance. Yeah, just for confirmation.
But why is that false? What word in the sentence makes it false?
See, it finds the minimum distance between two stations which has only direct connection. So if it has only
next one.
this one finds the path between two stations which has at most one hop route. Finds a path between the two stations which has if it has like.
Ma'am, your page is not visible.
She's not projecting it.
Yeah, my network is not good, so I'm not projecting actually. Yeah.
So the one-hop, the finds the path. Is that the problem? It is not finding the path. It is finding the
distance.
Is that the problem in this sentence? At most one hop is correct, right?
One hop, yeah, at most one hop is correct, right? Because one hop is like only direct or one hop.
Yes. So
yeah, finds the path between the two stations which has at most one hop route. Yeah, you are not finding the path, you are finding the distance.
Okay.
Yeah, activity questions are like you should solve after going through what lectures. If not, it will be like confusing only. Yeah, for me also, like, yeah, I haven't gone to the
And even after seeing the lectures twice, I couldn't understand this. Soon after listening to the lectures, I attempt the questions.
See, the thing is like you are here, it is like one hop distance, no? So you should go to the procedure one hop distance, what they have. Like there is supplementary contents, there is like what slides also, no? After watching the lecture, you can see that one hop distance what.
Okay, ma'am, I'll do that.
Procedure and you should answer. But the thing is like, yeah, these activity questions are like what? It is like not based on some logic, no? Yeah.
We have a solution and explanation for practice assignment and graded assignment. Like activity question, we understand and we do it. Because this is basically on logic, we want to know confirmation that what we have thought is right. We might get the answer, but whether the process we are following is right, that's what we wanted to know.
Yeah, I also think activity question also, if there is some solution, it is
just an explanation. This is a logic that has been used. I mean, at least for few questions, not for all.
Yeah, actually, see, previously this feedback is also not there for activity questions. This time only we are providing this feedback, just like because we thought like because we are seeing many questions in the forum and also discuss regarding activity questions.
Yes.
So I
Nowadays, yeah, for some of the questions, yes, like even in activity question 2 or 3, I think there's a very good explanation for one particular question.
yeah
That was
so
easy.
yeah, that's why, yeah, that's why this feedback is provided for few questions, like for difficult, if some people have stuck in that particular thing, then yeah, to help them only that feedback is provided. Yeah, we'll try to provide for all other questions also. But the thing is this, the questions, these questions generally, like whatever questions you have asked now, it does not involve any calculations, right? No iteration or something. It's just some logic, some based on some logic for that questions. Yeah, if lectures are, if
Ma'am, the feedback on the question 3 of activity 8.4, which she asked now,
yeah,
that feedback is more confusing.
that feedback is, see, that feedback is more that, see, if you watch the lecture and if you read the feedback, I think it will
No,
be good.
you please.
I think I should have watched the lectures twice or thrice.
You have watched the
No.
lectures twice or twice. See, immediately after watching the lecture, yeah, it will be easier, no,
See,
after watching the lectures to solve this.
Madam, the feedback is contrary to the question, actually. Feedback says 1/2 distance always stores the direct distance only between the stations.
Ma'am, sometimes in the revision lecture, you normally give a code block and you ring fence certain areas in the block, and the side you give explanation notes. That is the best way for understanding the codes. And we many times said this is the best thing if at all you want to really give us, that will help us to understand the code and build it up based on the explanations what we are receiving. But unfortunately, that type of explanations are not coming.
Today I did that only, no?
No, really. You started working on the notepad, but previous one, what they're shown is really the prepared notes. And he was walking us through the prepared notes. And there was sort of a handwritten animated things where we were able to really appreciate it very much. And we all said that this is the best thing we...
In which session?
In one of the revision session before the quiz. Before the quiz.
Achha, that is presentation.
Yes, that's a presentation, yes. So that is the best one what people can reach out and understand and take it forward for really working out the solutions.
But this is based on questions, right?
Yeah, that is
that
revision
is
of
already prepared. Question is prepared.
Yeah, that's right. Now what we are telling is after we finish that graded assignments, if you are not understanding it, that is the type of thing we need.
See, there is solution also. Yeah, you can go through the solution also. We are conducting sessions also. You can ask, right? You can point out your doubt. Yeah, I'm unable to understand here. You can
No,
tell
but
me.
what we are telling you.
See, you are expecting like everything. Like the thing is like, so I should display the code and I should explain the thing. It's not good, right? It will be difficult for you only in the exams.
No. I'm not really asking to give everything open. Just make us to think in and make mistakes and learn. That type of recycling process is always good. But what I'm trying to put up the point here is the lecture and the practice questions are not tied together, because we take a lot of time, 40 minutes, 50 minutes in listening to lectures. The meat of the matter in the 15 minutes investment is probably 15 minutes. But that 15 minutes really overhead of that one is another 35 minutes. And we are not taking out the message to the practice questions. That's what we are finding it difficult. So you got to really find out, you got to bridge the gap.
Yeah.
Because the lectures are not helping us as much as in any other subject like math and stat. Yeah, the lectures are really straight to the point and we can work it out, the solution. We do make mistake and we really able to understand where the mistakes are. But in CT, we are finding it extremely difficult. I don't know. Other students can really put up their voice whether I am telling rightly or I'm not, whether I am putting up the words rightly to put up the problem.
Yes, ma'am. Yes, true.
Yeah, the thing is like whatever that can be covered in the lectures, they have done their work. The professors have done their work. The thing is like, yeah, in the questions, no, it's like next level. If you are watching the lectures and if you're doing, yeah, everything won't be direct. No, in this is computational thinking. You should think somewhat.
No. I'm not complaining, but it is obvious that there
See,
is
it's
a gap.
not like other subjects like maths and stats. It's not like that. There is nothing like formula or something like that in this. There is like, yeah, you have shown a route of like you should proceed in that way. So the thing is like you should understand, you like, yeah, everyone's logic will be different. I won't tell this pseudocodes, everything which we have given should be executed in that way only. You can write other pseudocode which also in that
Yeah.
pseudocode also that same thing can be done, but in other way. The thing is like, yeah, so we can't enforce all this, right? We can't teach you like everything like this thinking. We can't teach you. We just will tell how to think, but we can't teach you this also, right? Yeah, you should think in that way, that we will tell.
I agree that it is not a mature subject like math or stat.
Yes.
It's an evolving subject and everyone is learning. From your side, you are learning to reach out to the students how to teach it. But we as students do have some points. Probably if we can connect these two things, you can identify a gap. There is a gap now.
Yes, ma'am. A huge gap between the lectures and the activity questions.
Yeah, somewhere there should be a bridging. We have to do it now. So what we are telling is probably you can just take as a prompt, and
the
you
thing
can.
why, see, activity questions are not cared that much because see, you won't get any such kind of questions in your in your exams. Activity questions are just like whether you have, if you have watched the lecture, then you should have understood that concept. Those questions are framed such that, okay, if something is not clear, so that questions are all that activity questions are based on the lecture only. Okay, if you are unable to answer the lecture, then what people will do will rewatch the lecture. So the thing is like just to confirm like you have understood all the concepts which are given in the lecture, just for that only, that questions. You won't get such kind of questions in exams also. The practice and graded assignments are like, yeah, you should go through them,
Yeah.
so that yeah, you like
Yeah, I
whatever.
think you're right. What you're telling is perfectly right. But first thing is we are seeing the lectures and working out the activity questions. Gradually, when we reach out to the practice questions, we are not thorough to attempt the practice questions. We are still cold there. We are not enough warmed up to really start working on to build up the course.
Is it for everyone? I don't see.
Yeah.
Mohan Raj, is it for you also? Like, are you unable to solve this after watching this?
Ma'am, actually, this
Most of
one
the questions
activity
we can
questions,
solve.
why we are asking doubts is we want to be clear. We know these questions are not going to be asked, but we want to be clear that we have understood the concepts, the logic, because somewhere
Yeah,
that
I
will be applied.
understood that.
Yeah.
I understood that. Yeah, I
And
understood.
before the exam, you gave us one fantastic slide, ma'am. That's 4, 5, and 6 covering. That was very good.
Exactly.
Yeah.
That is a slide I was.
It was very helpful, ma'am. In fact, every last moment we can just go through that. If it was given a bit more earlier, it would have been more helpful. We could have thought through that more because we had other subjects also. But it was very helpful, ma'am. Those slides are very helpful.
Yeah, we'll try to give this time also a little bit early. Okay. Yeah, the thing is like, yeah, but Subramanya Mohan is complaining that if you are watching the lecture, we won't.
No. I'm not complaining. I'm just telling.
Okay, you are telling like,
I'm just
yeah, you are
requesting
telling. See, you are telling like if you watch the lectures, then you are unable to solve practice and grid assignment questions. Is it for everyone, or yeah, should I
No,
assume?
ma'am, we require more practice. It is on our side. I feel if we do 3-4 times the same thing, we will get the hang of it. It is just not one time affair there, like how it was in the first 2 weeks. Now it
See,
is,
yeah,
yes.
if you are, see, if your basics and everything is clear, if first 4 weeks are clear, and see, if the content is clear, then you can solve it. Actually, yeah, the thing is
Actually,
you
the
can have,
lectures contents are very clear. There is no doubt about it. But for us to apply, see, there is some gap within our mind to translate these lectures into the problems.
yeah,
The
that
gap
is
is
there.
within us.
That
So
will
that,
be there. Yeah.
yeah.
I
So for
think
that, we need practice. That's what, if you give small codes, which you were giving, in previous small pseudocodes you used to give for even for exams, that really strengthened our basics. So even the other day also we were discussing for dictionary also, if you give us some small this thing and do more practice of it.
Actually, madam, on the graded question or whatever question, for few of the questions, I think there was a presentation which showed what was the dictionary status after every code.
Yeah.
I think 1 or 2 samples like that would help for easier understanding.
Yeah, I think Mohan is perfectly right. What I was expecting in this n by n matrix, each element is a dictionary. It is a dictionary. So if you really have sort of a row and column references within the dictionary with the train name and train number and other things, then probably, in fact, we took little while to understand what an element in the n by n matrix.
Yeah, that's, see, today, like, I haven't given presentation, I just use note to write, because yeah, see, if I give some presentation, if I make slide, then you won't like filling each and every element, that won't be clear. I felt like, yeah, it will be good to write about, to explain immediately, to explain and write simultaneously, parallelly.
That is the
Yeah,
point I was trying to tell,
yeah,
because
that's what I did. Yeah, if it is not clear, then I can make presentation for that. Yeah.
what I'm trying to tell is, before walking through the code, every one of us has to have the same page of vision. Then only the code really makes same sense to everybody. But I believe the n by n matrix and the elements in the n by n matrix, I don't think everybody visualizes the same way what you expect us to really see it. So that such a situation is better to have some few rows filled in, and when you walk us through, then it helps us to understand exactly what we should do. I don't know whether others do feel that way or not, because it's my perception. Whether others do have that same type of gap or not, I can't speak for it. If it is my problem, it is me. I have to revise it. If it is a common problem, then it is bridging the gap type of thing.
Yes, I agree. I think when we do also, we have to do the same thing. When we are solving that graded or practice assignment also, then we imagine a sample case, then we fill the dictionary, and then we fill the matrix. Then we try to see how the matrix looks like, and then we go through the code. Then it is easy to understand. So we also have to do the same thing. But while in a discussion session, if there is one question which is done that way, I think it will give more clarity.
Yeah.
If one question is prepared with the dictionary status, content of the dictionary, how it will look, how it will be there after each and every code sentence, and then I think it will take us through very easier.
Yeah.
The other questions can be based on whatever people are asking, but at least one question can be prepared to explain the code in detail.
Yes, that's the best thing is. And side by side, if you really prepare a table which shows the return values for each of the code lines, then it's very clear. Only one problem, if we start working that way, then I think the rest is on us. We got to really do that same amount of investment and start building it. But at least one we want to see it.
Yeah, okay, we'll plan like
Yeah,
we'll
that will be
try to
helpful.
explain at least one question, like everything like properly clear for everyone. So yeah.
Okay, that would be very helpful. Thank you, ma'am.
Thank you, ma'am.
Yeah.
Thank you so much, ma'am. Thank you so much.
Thanks everyone.
Thank you, madam.
Thank you. Thank you.
Thank you, ma'am.
Yeah, thanks everyone for joining.